Welcome to today's deep dive. Have you ever walked into a place that is just, designed entirely around visual appeal?
Oh, like a high-end local fish store.
Exactly. You walk in, and there is a very clear expectation right from the jump. Everything in that room is actively competing for your eye.
Right, it's a totally visual space.
Yeah, you have neon tetras schooling together like these tiny glowing aquatic billboards,
Hmm.
and you've got premium betta fish dragging around those luxurious flowing fins like they're walking a red carpet.
Don't forget the corals glowing under those heavy actinic blue lights.
Oh, for sure. It's an environment curated for maximum aesthetic impact. Basically, everything in the room is screaming, "Look at me."
It is a completely superficial economy, honestly. I mean, the retail space in a local fish store is notoriously expensive to maintain.
Yeah, I can imagine.
So the prettiest fish naturally secure the premium eye-level tank space. We are just biologically drawn to color, to movement, to dramatic forms, and the industry caters directly to that impulse.
Which perfectly brings us to the subject of today's deep dive. We are looking at this brilliant and actually surprisingly philosophical piece of writing from April 2026.
From the blog Notes on Fishkeeping, right?
Yes, specifically part 244 in a series by an author named Ang. And this post zeroes in on a fish so completely devoid of aesthetic value that it forces a really fascinating question.
Why on earth would anyone want to keep such an ugly fish?
Exactly. Our mission today is to explore that. We want to see how a creature's hidden biological machinery can completely override a total lack of visual appeal.
And Ang frames this exploration so perfectly by putting us right there in the fish store aisles. The post is titled Finding the Appeal of the Silver Scat.
Or, if we're being scientific, Selenotoca multifasciata.
Right. And Ang really doesn't mince words about that initial reaction to seeing it.
No, not at all. Let's actually paint a picture for you exactly what Ang saw, because you really need to understand why the immediate reaction was so incredibly dismissive.
It's not a looker.
It is not. When Ang looked at the silver scat, it was essentially just a flat, plain silver oval. It had these dark, muddy, kind of mottled vertical stripes down its sides.
No dramatic fin shapes either.
None. Zero iridescence, no vibrant color palette. It is like the ultimate aquatic wallflower.
Yeah, if you were wandering into a store hoping to build this vibrant underwater garden in your living room, your eyes just slide right off the silver scat.
Totally.
It simply doesn't register on the standard spectrum of ornamental livestock.
Okay, let's unpack this for a second. Because if the aquarium hobby is fundamentally about creating a visual display, I want to look at this through, like, a beige commuter car analogy.
Oh, I like where this is going.
Imagine walking into a high-end luxury car dealership. You are surrounded by sleek, aerodynamic, candy apple red sports cars.
The best of the best.
Right. And then right in the middle of the showroom floor, taking up prime real estate, is a boxy, beige, 1998 four-door sedan.
It makes no sense.
As a consumer, you would naturally ask why on earth it's taking up floor space. So, applying that to the silver scat, why does a retail store waste a filtered glass box on a dull fish that nobody wants to look at?
Well, what's fascinating here is that the aquarium trade, at its highest levels, isn't strictly driven by what looks good.
Really?
Yeah, it's actually heavily driven by what a fish can biologically do. Ang's research reveals that the silver scat isn't in the trade to be a visual centerpiece.
So why is it there?
It's stocked because it possesses two incredibly rare biological traits. It perfectly represents this total conflict between our human desire for pretty things and the sheer pragmatic brilliance of evolutionary utility.
Oh, wow. So it's the beige commuter car, but under the hood is literally a multi-million-dollar hypercar engine.
Exactly.
And not just any engine either. It'd be like an engine built to run on gasoline, diesel, or like leftover cooking oil without ever stalling out.
That is a highly accurate way to look at it, actually. Ang introduces two massive scientific concepts that completely define the silver scat's biology:
Let's hear them.
euryhaline and amphidromous. These are the hidden mechanics that make the fish so incredibly valuable.
Let's get right into those mechanics. The first term from the blog post is euryhaline. And in short, this just means the silver scat can tolerate a massive range of salinity.
Massive.
We are talking about surviving comfortably in environments ranging from 100% pure freshwater to 100% full-blown ocean marine water.
Which is mind-blowing because for the vast majority of aquatic life on Earth, the boundary between fresh and salt water is this impenetrable, invisible wall.
You can't just cross it.
No, crossing that line means catastrophic systemic failure for almost any other fish.
Okay, here's where it gets really interesting. I want to push on this a bit because we casually just say a fish, tolerates salt water.
Right.
But isn't moving a freshwater fish into the ocean basically like a human stepping out of Earth's atmosphere onto the surface of Mars without a spacesuit?
Pretty much, yeah.
So what is physically happening to the animal's cells that makes this so deadly for normal fish?
If we connect this to the bigger picture, it all comes down to a relentless force of physics called osmotic pressure. And of course, the biological defense against it, which is osmoregulation.
Okay, osmotic pressure.
Right. Nature always wants to find a balance. So if you put a standard freshwater fish into the salty ocean, the heavy salt concentration in the surrounding water aggressively pulls the moisture right out of the fish's cellular walls.
Wait, it pulls the water out?
Yes. The fish will literally dehydrate and shrivel up internally while completely submerged in water.
That is such a terrifying paradox to think about. Dying of dehydration while you are literally swimming in an ocean.
It is brutal, and the reverse is equally brutal, by the way.
What happens then?
If you take a saltwater fish and drop it into a freshwater river, the fresh water rushes into the fish's salt-heavy cells until they expand and literally rupture.
Oh, wow.
Most fish are hardwired to handle only one side of that equation. Their kidneys and gills are optimized for one specific level of ambient salinity.
So to survive crossing that boundary back and forth, the silver scat has to be carrying around some kind of dynamic biological spacesuit.
That's a great way to put it.
How does that spacesuit actually function? Is it like actively filtering the water as it swims?
Yes, it's an active, highly demanding mechanical process. To be euryhaline means the silver scat possesses specialized cells in its gills called chloride cells.
Chloride cells, got it.
In the ocean, the fish is constantly drinking seawater to avoid that dehydration we talked about. And those chloride cells act like heavy-duty microscopic pumps.
Pumping out the salt.
Exactly. They aggressively push the excess salt out of the body, while the kidneys produce highly concentrated urine to conserve as much water as possible.
Okay, but think about this. When it swims up a river into fresh water, that whole system would suddenly work against it, right? It would be pumping out salt it desperately needs.
Precisely. And this is the magic of the silver scat. When it enters fresh water, it basically flips a physiological switch.
It just switches modes.
It stops drinking water entirely. The chloride cells in the gills reverse their function.
Oh, way.
Yeah, instead of pumping salt out, they actively pull trace salts in from the surrounding fresh water.
That is wild.
And the kidneys shift, too. They start producing copious amounts of very dilute urine to constantly flush out the fresh water that is trying to flood the fish's cells.
Just thinking about the cellular mechanics of that is exhausting. The biological tax, the sheer amount of metabolic energy required to run those pumps, reverse them, and constantly manage that internal water pressure.
It's massive.
It has to be enormous.
Yeah.
Why would a fish evolve to burn so much energy just to tolerate different water types?
Well, you've hit on the exact reason for the second trait Eng outlines. The energy cost is astronomical. Which brings us to the term amphidromous.
Oh, okay.
Euryhaline is the mechanical ability to survive the change in salinity. Amphidromous is the lifestyle of actively migrating between these environments to actually fuel that biology.
Let's trace that lifestyle then, because Eng maps out the life cycle of the silver scat in the post, and it shows exactly how they pay that biological tax.
It's quite a journey.
They start their lives out in the full marine environment of the ocean, right? Or at least in highly salty estuarine water. So they are born into high salinity, completely surrounded by the marine food web.
But they don't remain on the reef. As they enter their juvenile phase, they embark on this massive migration.
Leaving the ocean entirely.
Leaving the ocean. They push through the brackish estuaries and they swim deep into freshwater streams where they settle into low salinity, tangled mangrove swamps.
Think about the sensory shock of that transition. They are leaving the vast, clear, deep blue ocean, and they are navigating into muddy, tannin-stained, winding freshwater rivers.
It's a completely different world.
The temperature fluctuates wildly, the water clarity plummets to near zero, and the pH totally shifts. All while their internal chloride cells are actively reversing polarity just to keep them alive.
Right.
Why make that grueling trip?
because of what the freshwater mangroves offer them. By moving into these murky streams during their most vulnerable juvenile phase, they escape the apex predators of the open ocean.
Oh, groupers and sharks.
Exactly. The larger predatory fish don't go into the freshwater, but more importantly, estuaries and mangroves are incredibly nutrient-dense.
Ah, the food.
They offer a massive concentrated food web of insects, plant matter, and small crustaceans.
So they need that dense calorie source to fuel the massive metabolic cost of their osmoregulation engine as they grow.
Bingo.
They are trading the stability of the ocean for the chaotic but highly nutritious safety of the freshwater.
And they spend their entire youth growing strong in that freshwater environment. But once the silver scat matures into a full adult, a biological clock triggers,
And it goes back.
it makes the journey in reverse. It travels back down the rivers, through the estuaries, and out into the crushing salinity of the full ocean.
And it just fires up those gill pumps in the opposite direction all over again.
All for one specific purpose, right? To reproduce in the marine environment. Yes, it is a staggering life cycle.
It really is. But as fascinating as this evolutionary journey is, I want to pivot back to the hobbyist for a minute. I want to look at the glass box in the living room.
Back to the fish store.
Right, because earlier I asked why a fish store would stock this dull fish. If it's constantly migrating in the wild, what is its utility to someone keeping an aquarium?
This is where Ang's blog post gets incredibly practical. The specific timeline of the silver scat starting in salt, growing up in fresh, and returning to salt aligns perfectly with one of the most difficult transitions in the entire aquarium hobby.
Oh, interesting.
Ang refers to the silver scat as the ultimate bridge fish.
Let's talk about that bridge. As anyone who has tried to make the leap from a standard planted freshwater tank to a marine setup knows, the margin for error is absolutely brutal.
It really is.
Moving from fresh to saltwater isn't just about dumping some salt in a bucket. It's a completely different biological filtration system.
Exactly. The beneficial bacteria that process waste in a freshwater tank will die immediately in saltwater.
Instant crash.
So when a hobbyist wants to convert a tank or even just start learning marine chemistry, they face a very high-stakes learning curve.
Yeah, you have to mix synthetic salt, carefully measure the specific gravity with a refractometer,
And endure heavy ammonia spikes as the new marine bacteria slowly establish themselves. One wrong move, and the entire ecosystem crashes.
So what does this all mean? The absolute irony of this dynamic is that this profoundly ugly fish is actually a trainer for the human.
It really is.
It is a living safety net.
It acts as the anchor during that entire chaotic transition phase.
Well, wait, let me play devil's advocate here for a second.
Go for it.
If a hobbyist wants to practice transitioning a tank or cycle a new marine setup, why risk a fish at all? Why not just do a fishless cycle? Or if you must use a fish, buy a cheap, hardy freshwater fish like a zebra donio.
I see what you're saying.
Why seek out and pay premium prices for a silver scat?
Because a zebra donio will die the moment your specific gravity hits 1.005. A fishless cycle is chemically sound, sure, but Ang points out the psychological and practical benefit of the bridge fish. Fishkeeping is a very hands-on, observational hobby.
People want to watch the fish.
Hobbyists want to observe how livestock reacts to the environment. The silver scat allows you to buy a juvenile, place it in your existing standard freshwater tank, and it is perfectly happy.
Because that is its natural juvenile habitat.
Precisely.
And then, when you decide you finally want to learn marine keeping, you don't have to break down the whole tank and start over in an empty glass box.
Exactly. You can slowly begin adding marine salt over a period of weeks or even months. You are artificially recreating the silver scat's natural journey down the river to the ocean.
Wow. And while a normal freshwater fish would go straight into osmotic shock and die from the slightest miscalculation, the silver scat just effortlessly fires up its chloride cells.
It completely forgives your mistakes.
That's amazing.
If you raise the salinity too fast 1 week, or if the water chemistry fluctuates wildly while the new marine bacteria are colonizing, the scat just paces the glass entirely unbothered.
It's just doing what it evolved to do.
It allows the hobbyist to practice, to slowly transition an entire tank's ecosystem without instantly failing. It literally walks across the bridge with you. This raises an important question about how we fundamentally value nature, and specifically how we value the animals we bring into our homes.
How so?
When Ang first looked at that tank in the local fish store, the value metric was entirely static and visual. The question was simply, does this animal look pretty right now in this exact moment?
And the answer was a resounding no. It looked plain, just a beige car.
But the true utility of the silver scat isn't static. Its utility is dynamic. Its value lies entirely in its invisible ability to adapt to extreme environmental change.
It's not just a decoration.
No, it isn't a showpiece. It is a living mechanism that connects two totally different worlds of the hobby.
It totally redefines what makes an organism valuable. We started this deep dive looking at a fish that Aang explicitly called ugly.
A wallflower.
A fish that most of us would walk right past in the store without a second glance, wondering why it was taking up premium take space instead of, a brightly colored discus or neon tetra.
It appeared to have absolutely no right being in a visually driven industry.
But by looking closer, by actually reading the biological instruction manual of this plain silver oval, we uncovered a euryhaline amphidromous marvel.
A true marvel.
We found an animal that possesses the internal machinery to defy the laws of osmotic pressure that govern almost everything else underwater.
Right.
We found a creature that literally bridges the gap between fresh and salt water, gently guiding ambitious hobbyists into a whole new level of their craft.
And I think Aang's observation leaves us with a thought that stretches far beyond the glass walls of an aquarium.
Where does it take us?
Well, we just spent a significant amount of time detailing the radical internal machinery required for a seemingly mundane fish to transition seamlessly between two completely alien aquatic worlds just to survive.
Yeah, a massive biological effort.
It really makes you wonder, what other unassuming, perfectly plain things in our daily lives possess that kind of hidden depth?
Oh, that's interesting.
Or even the totally unremarkable people we pass on the street every single day, who's secretly navigating two totally different worlds.
Wow.
What invisible, magnificent superpowers are operating right now, just beneath a surface that we have already judged as plain and ordinary?
That is such a profound realization to leave off on. We judge the surface so quickly, but the true mechanical brilliance is almost always hidden under the hood.
Always.
Thank you so much for taking this deep dive with us today. We hope you walk away looking at the plain, the drab, and the unassuming things in your world with a lot more curiosity. Until next time.